Hi guys, today we are here with tons of talks about the exciting and surprising news of SpaceX's completion of all tests for Starship's next orbital launch, as well as the Booster-9's static fires test. Another surprising news of India's successful mission called Chandrayaan-3. So today's video is full of exciting and thrilling knowledge for all of you guys. Before starting the video, if you're new to our channel, don't forget to subscribe and press the bell icon so you will never miss an update in the future. In today's video, we will cover: has SpaceX completed all the tests for Starship's next orbital launch? What are the results of the Booster-9 static fire test? What are the details about Chandrayaan-3? Now, let's start the video. Booster-9, with its freshly installed hot staging ring fastened to its top, is getting ready to be rolled out to the launch pad for additional static fire testing. The boost was moved adjacent to the launch mount on Tuesday after completing the 2-hour drive, perhaps for the last time before its orbital launch. Chopsticks hooked the extremely heavy bites lifting hardpoint shortly after, hoisted it, and then set it down onto the pad. Although I know what you guys are more interested in, last week's static fire test, SpaceX needed to do a few static fire pre-tests, which made this lift intriguing because normally we would be able to view the engines. This was preceded by pre-tests, all of which were conducted on Wednesday. First, the Raptor igniter was tested, then the Fire X detonation suppression system. The booster then underwent a brief spin after being partly filled. The primary test of SpaceX's engines, which doesn't involve ignition but speeds up the turbo pumps and lets fuel flow, was carried out on Friday. The Booster-9 in its entirety static fire as the live streams, and we saw the water day illusion system fire up, and there it goes. We later had confirmation that all 33 Raptors ignited with the static fire, lasting the full length. In the end, only 2 engines prematurely shut down, indicating that this would have reached orbit. Furthermore, it appeared as though the launch pad would have stood up if it had been an actual launch, with no more than one other engine failing during the ascent. Since no rock tornado was created during this test, both Ship 25 and Booster-9 have probably now completed all pre-flight requirements for the second Starship orbital launch. According to a tweet from SpaceX, the test generated about 7.9 million pounds of thrust, or about 3,600 metric tons. That's a lot, you say, but the booster is throttled down during static fire testing because, despite the enormous power, it only produces 7,590 metric tons at full throttle, which would be too much for the launch mount hold clamps. Starship QD Arm Test Booster-9. As part of the procedures necessary to have all systems prepared for launch, we witnessed a full-speed test of the Starship Quick Disconnect Arm in addition to static fire testing of Starship QD Arm Test Booster-9. When will the following orbital launch occur? Based on current indications, it may be less than 2 weeks away. This is based on a recent notice to mariners that SpaceX filed with the US Coast Guard that details where any rocket operations will be taking place and where areas of potential debris will be. It is important to note that this document states that the next Starship launch will be on or around September 8th or the following Friday. Additionally, SpaceX's FCC license will be renewed successfully on September 7th, leaving just a launch license to be obtained. Remember that SpaceX didn't have a license to launch Booster-7 and Ship 24 until after business hours, so the absence of a launch license at the moment isn't a clue that it would cause a delay. Chandrayaan-3. The third Indian lunar exploration mission under the Chandrayaan program of the Indian Space Research Organization (ISRO) is called Chandrayaan-3. Like the Chandrayaan-2 mission, it comprises a lander named Vikram and a rover named Pragyan. To prepare for the lander's powered descent, the propulsion module sent the lander and rover combination into lunar orbit. On July 14, 2023, Chandrayaan-3 was put into orbit. India became the 4th nation to safely land on the moon and the first to do so close to the lunar south pole after the spacecraft entered lunar orbit on August 5th and the lander made contact with the moon on August 23rd at 12:32 UTC. 3 key parts make up Chandrayaan-3: a propulsion module, a lander, and a rover. The lander and rover combination is propelled by the propulsion module into 100 km, 60 km lunar orbit. It resembles a box with a sizable solar panel installed on one side and the intermodular adapter cone, a cylindrical mounting device for the lander, situated on top. The gentle moon landing was made possible by the Vikram lander. Additionally, it has a box-like design, 4 landing legs, and 4 landing thrusters that can generate 800 Newton of thrust. It is equipped with a rover and several scientific tools for on-site analysis. Unlike Chandrayaan-2's lander, which had 5 engines with the 5th being centrally located and only capable of fixed thrust, Chandrayaan-3's lander includes 4 variable thrust engines with the ability to change the slew rate. The attitude increase during the camera coasting phase was one of the primary causes of Chandrayaan-2's landing failure. By giving the lander complete control over attitude and thrust throughout the whole fall, this was eliminated. With Chandrayaan-3, the attitude correction rate rises from 10 degrees on Chandrayaan-2 to 25 degrees. The Chandrayaan-3 lander also has a laser Doppler velocimeter (LDV) that enables attitude measurements in 3 directions. Compared to Chandrayaan-2, the impact legs are now stronger and instrument redundancy has increased. Based on previous photos from the Orbiter High-Resolution Camera (OHRC) on board Chandrayaan-2's orbiter, it will target a more exact 4 km by 4 km (2.5 miles) landing zone. To increase the lander's survivability in the case of descent and landing failures, ISRO strengthened structural rigidity, increased instrument polling, increased data frequency and transmission, and included additional multiple contingency systems. A 6-wheeled vehicle with a mass of 27 kilograms (57 pounds), the Pragyan rover. Its dimensions are 397 mm (1.302 feet) into 750 mm (2.46 feet) into 917 mm (3.009 feet). The rover is anticipated to collect a variety of data to aid in the study of the lunar surface's makeup, the presence of water ice in the soil, the timing of lunar impacts, and the development of the moon's atmosphere. Launch. The LV-M3-M4 rocket carrying Chandrayaan-3 lifted out on July 14, 2023 at 9:05 UTC from the Satish Dhawan Space Centre's second launch pad in Sriharikota, Andhra Pradesh, India. It entered an Earth parking orbit with perigee and apogee distances of 170 km and 36,500 km respectively. Chandrayaan-3 was successfully inserted into an orbit around the Moon on August 5th by ISRO following a series of Earthbound maneuvers that had previously put the spacecraft in a translunar injection orbit. The ISRO Telemetry, Tracking and Command Network ISTRAC in Bangalore served as the operating base for the LOI operation. The last stage of the mission was launched on August 17 with the Vikram lander detachment from the propulsion module. On August 23, 2023, the lander's 4 engines ignited in a braking maneuver 30 km (19 miles) above the Moon's surface as it neared the low point of its orbit. The lander reached a height of 7.2 km (4.5 miles) above the surface after 11.5 minutes. It held this position for roughly 10 seconds before stabilizing itself with 8 smaller thrusters and rotating from a horizontal to a vertical position while continuing its descent. It then lingered there for around 30 seconds to choose the best landing place, using 2 of its 4 engines to slow its descent to about 150 meters (490 feet) when it touched down at 12:32. Result of Chandrayaan's landing on the Moon. In addition to deploying the Pragyan rover to investigate the Moon's cratered surface and using integrated cameras to relay back videos of its surroundings, Chandrayaan-3 has also begun working on the research goals that were intended for a 2-week stay on the Moon. On August 25, 2023, a video showing the rover departing the Vikram lander on the ramp and entering the Moon was posted online. The video was uploaded by ISRO in a thread on X that also featured footage of the lander approaching its landing spot and creating a cloud of dust as it landed. A first-of-its-kind dataset from CHA-STE, Chandra's Surface Thermophysical Experiment, one of the 4 instruments on the lander module, was also made public by ISRO. With the overarching goal of constructing a thermal profile of the Moon, CHA-STE was designed to investigate the heat conductivity of the Moon's surface and quantify the variations in temperature at various locations on and below the surface. According to ISRO, first ever in situ measurements made by the Pragyan rover's Laser-Induced Breakdown Spectroscope (LIBS) instrument on August 29th unambiguously proved that sulfur is present on the lunar surface close to the South Pole. Sulfur has been discovered for the first time at the South Pole, even though sulfur has been found elsewhere on the Moon. In an interview with New Scientist, John Bridges, a professor of planetary science at the University of Leicester in the UK, said the Moon's low pressure made it unlikely for Chandrayaan-3 to find liquid water close to the surface, even in regions where the temperature was above freezing point and water would not be trapped in ice because it would boil away. However, at lower depths, the pressure might rise enough to allow liquid water. Now make sure you are subscribed so that you don't miss any videos. I hope you enjoyed today's video, and if you did, then give this video a thumbs up and don't forget to share because it helps support what I do here. Comment down if you want more videos like this.